Hey everybody. So I have been working all week on RF field mapping, and I finally got a demo map, or an interactive map actually, up on the blog of the RF field maps. And so I just kind of wanted to walk you through how to use it. And so the first thing I wanted to do though was show you kind of the inspiration for all of this. I was using my ham radio on top of One Plaza a few weeks ago now, and had the antenna, a vertical antenna, in this tree right here, and the radio down here in this planter. And my first contact was to Alaska, which was not super surprising, because I talked to Alaska AK7LC, I believe. It might be AL7KC, that sounds better, all the time. But this time there was a really big apartment tower in the way. And so it was a little perplexing that being that close to the tower, the signal had still reached to Alaska. And so that's what inspired all the mapping. And now let me kind of walk you through, I'll walk you through how to use the map. So the map is on the blog page that I posted along with this video. It's easier to use when it's big. So first thing is, when you want to play with the map, go to full screen. Okay. Second thing is what is the map actually mapping? So I'm going to turn on one of the RF shrink shells here, going at 500 meters, and you're going to see what is an interference pattern for radio waves in a sphere 500 meters away from the transmitter. And so here's what is going on. The map, or actually the model, is modeling reflections from the transmitter, which was sitting right about here, off of not only that building that got into the way to Alaska, but also the surrounding buildings. So Alcoa Tower was already there in my original model. This apartment building was in my original model. There's actually a conduit that was on the roof of the smaller building behind me that runs right along here. That was in the original model. And then all these other buildings I pulled in through OpenStreetMaps automatically, turned them into CZML, and then had ChatGPT modify the modeling script for me so that it could pull these CZML buildings into the model. And so what you're looking at on the map on the blog site is actually what happened to the strength of the radio waves, where their phases lined up and phases canceled each other out based on building reflections down here near the transmitter site. So to use the map, go ahead and blow it up to full screen, and you have a little control panel over here that controls the different data layers. This is some more code that I wrote with ChatGPT. It's portable. I'm going to use it on a lot of my maps, and what it does is you can see the QSOs right now, the radio contacts. And by the way, as far as from a higher altitude perspective of all this, these are the places that the radio contacts went to that day. So Alaska was by far the furthest place away, but made, there's actually two contacts right here that are really lined up near each other. And then 3, 4, made 5 more contacts as well. So that's the radio contacts. And the point is that by using the data source control, we can turn them off, so we don't have to see them anymore if we don't want, and we can turn them back on. And then the same thing with the RF interference layers. And so that is the 500 meter model, 1,000 meters away from the source. Interference looks like this. And this was actually really nice. Early on, talking with ChatGPT, one of its earliest explanations was, well, you can actually diffract off of this roof edge, and what that's going to give you is a really low beam. And sure enough, if you put in the buildings and model, there is a nice yellow patch, which means that it is high field strength right here. By clicking on each of the points, you can get a relative dB of how high the electric field of the radio wave is at that point, compared to the strength of the radio wave field radio frequency field everywhere else on this wedge. And so it was really nice that, yep, Alaska lined up. The two strong signals up to Washington also kind of land in the middle of yellow zone. And the other thing is, if you're wondering how the angles are calculated, they're actually calculated using National Oceanographic and Aerospace data about the F2 layer at the time the call was made. And so what you're literally seeing is that's how high the F2 layer was at that point, the ionosphere, when I talked to this contact along the green line. As it turns out, the Alaska path was just visible enough that a 7-degree takeoff took it out and up to Alaska. So you can turn off, if you don't want to see all the wedges at once, you can turn them on and off using this panel. And so if we go to 250, we get this wedge closer into the source. And so that's what the data source panel does and how you can use that. I'm going to go ahead and turn on 1000 and turn off 250. And then the last thing I just kind of left in, it wasn't really intended to be in this map, but I'm reusing this map, and it kind of makes me giggle a little bit. If you click on a QSO, and you got to wait a little bit because it's going out to talk to the USGS, you can get elevation information on the path along the first 600 feet of the QSO. And so what you're going to see maybe is a green dot out there. Yep, there's a green dot on the street. So that's 600 feet. We just had folks arrive. And then if you drag along here, what you're going to see is the blue dot. If you drag along the data, the blue dot is where along the path the data came from. And I think it's really interesting that what you're seeing right here, if you look, you're only looking at a difference in elevation between about 10 3/4 feet and 12 feet. Right along here, the trees, the service that did the elevation estimations is having a hard time rolling out the trees from the ground. So I think that's really cool. But at any rate, that is how you use the map. If you reduce it back down, you can see the entire blog page again. And there is a link to the code both in this article and it's right there, and in the posts for this video. So hopefully those help. I will be writing up other tools like the data viewer panel right here over the next few days, and I will also be writing up the CZML building selector that actually uses the data panel that allowed me to choose which buildings to include in the model, and that's another tool that I wrote as a result of this project. So anyway, have a good morning, everybody. Have a nice weekend. Talk to you soon.
Dun 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 dun, Toucan Radios!
Woo!